So our warm-up for today is talking about closed sets. If it's closed, all we have to do is state closed. If it's not closed, then we have to justify. So number one, we're trying to figure out if I divide any two integers, can I get a number that's not an integer? So if I think about, like, if I divide two negatives, I get a positive, well, that's still an integer. If I divide a negative and a positive, it's a negative, that's still an integer. But I have to think of, can any division problem turn into a decimal or a fraction? Because decimals and fractions, even if they're negative, are not integers. And yes, my example is if I take -3 and divide it by 2, I would get -1.5. That's not an integer, even though it's negative, it's just rational. So this is not closed. Now, obviously, -3/2 is not the only answer to this. As long as you have two numbers, whether they're negative or positive or one of each, that when divided turn into a decimal or stay a fraction would be correct. Number two, we have to take these numbers and see if they're closed by multiplication. So you should have started and said, okay, -1 times itself. Well, that's +1. So that's good. -1 times 0. That's 0, that's in the set, so we're good. And then -1 times 1 is -1, and that's also in the set. Then I need to do 0 times itself, which is 0. That's in the set. Then I need to go 0 times 1, which is 0. That's also in the set. And then I move to the 1. Well, I've already multiplied 1 times -1 and 1 times 0. So the only thing to do is multiply it by itself, which is 1. That's also in the set. So yes, under multiplication, this is closed. Here are your homework answers from last night. Just kind of like in the first warm-up, 7 through 10, there's lots more possibilities for answers. Negative integers, as long as it's a negative whole number, then you're correct. A negative rational number that's not an integer has to be either a negative decimal or a negative fraction that can't be simplified. 9, there is no such thing as an irrational integer. They are two separate categories. Cannot combine the two. And number 10, a negative irrational number, any decimal that keeps on going with a negative sign, or a square root that's not perfect with a negative sign as well. 16 through 20, negative integers under subtraction are not closed, because if you subtract a negative, it turns into a positive, and that could give you a positive integer. 17, adding two integers is always going to give you another negative. So adding two negative integers will always give you another negative. So yes, that's closed. Rational numbers by division, because even if you get a decimal, that's okay. If you get a fraction, that's okay. And there's no way to divide two rational numbers to get an irrational number. 19, that set is not closed under multiplication, and you get an example right away. -2 times itself is 4, and that is not part of the set. You also could have done 2 times 2, which is 4, not part of the set. Or -2 times 2, which is -4 and not part of the set. Number 20, negative numbers under multiplication, negative integers, is not closed, because if you multiply two negatives, you end up with a positive. Today, you're just going to spend more time working on this page, finishing the front and doing a couple questions on the back to make sure you understand 2-2. There is an answer key in the class, so make sure you check your answers as you go through. The only answers that you'll check tomorrow at the beginning of class is the second assignment, which is the ready to go on kind of your review for your quiz tomorrow.